In section 1.3, we will talk about some basic terminologies and concepts before we really go into thermodynamics, okay? Because we would like to build a better foundation for learning thermodynamics so that you can learn the basic vocabulary that we will use in thermodynamics for our communication, okay? So we will talk about the first concept, that will be system and control volume. Well, a system is just something you would like to investigate. Right? This can be masses or a region in space. For example, suppose there's a cup of water here. Okay. Well, like this. Okay. Well, you can choose to study only the water. That is the region bounded by this dotted line. I marked it as A. Or you can study the cup together with the water, like this. Okay, another dotted line enclosing the entire cup. I would mark it as B. Okay, or you can just talk about the space in the cup. Okay, that is the region marked by this black dotted line. Okay, I will use C to denote this system. Okay, the choice of system is very important in solving engineering problems, as we will see in later chapters and courses. Well, okay, after that, we will talk about another term called surroundings. Oh, it is just the things outside the system, okay? System and surroundings are separated by real or imaginary surface. We call that the boundary, okay? You can fix the boundary or make it movable, okay? For example, I have a piston cylinder device here, containing some gas, okay? And if you choose the gas as a system, when you heat this piston cylinder device, it will expand. And this boundary will move to an upper position, okay, when the gas expands, okay? This is an example of moving boundary, okay? And the other surface will be the fixed boundary, as they do not move. A system can be classified as open or closed. Closed system refers to those with no mass flow. Okay, this can be a covered container or an open can of soft drink, etc. Okay, we also call closed system control mass because the mass content there will be fixed. Okay, but note that energy can cross the boundary in this case, as we can see in the warming of Coke at room temperature. Suppose you take a soft drink can out of the refrigerator, then it would have a rise in the temperature and gradually become warm if you put that inside a room. Okay. If energy transfer is also prohibited across the boundary, the system will be isolated. Okay, will be isolated. For open system, we also refer open system to be a control volume. We use CV to be the short form of control volume. Okay. Open system or control volume is just a region of space chosen for investigation. Okay? Both energy and mass can cross the boundary. Okay? A properly selected control volume can greatly simplify the problem. Okay? For example, you can choose a control volume like this inside this nozzle. Okay? You will gain experience on how to choose this kind of control volume in later sections. Or you can also choose this kind of control volume inside this piston cylinder device with some input. Okay. There are also cases that the size or shape of control volume changes throughout our analysis, but these cases would not be studied thoroughly in this course. Okay, but you will see that in fluid mechanics. The surface that encloses the control volume is called a control surface. That means okay, this surface of the dotted line, okay, we call that the control surface. And you can see there will be some real boundary as well as imaginary boundary. And in this case, mass can flow through across this boundary.